Right now, Voyager 1 is still transmitting signals back to Earth from nearly 25 billion kilometers away, and NASA has no way to stop it. For over a year, those signals carried something nobody expected. Not telemetry, not star data, gibberish, a code no computer on Earth could initially read. And what engineers found buried inside those signals is the part they're afraid to say out loud. Voyager 1 is the farthest human-made object ever built. NASA launched it in 1977, before personal computers, before the internet, before most people alive today were born. It used a gravity slingshot around Jupiter and Saturn to escape the solar system entirely. By 2012, it crossed into interstellar space, the vast, cold darkness between star systems. Nobody had ever sent anything there before. Nothing has gone farther since. Right now, Voyager 1 is traveling at roughly 61,000 kilometers per hour. It is so far from Earth that a radio signal moving at the speed of light takes over 22 hours just to reach it. When engineers send a command, they wait 45 hours for a response. That's almost 2 full days to say one thing and hear one reply. That distance matters, because it means when something goes wrong out there, NASA is essentially helpless. In May 2022, something went wrong. Voyager 1 kept transmitting. The signal was strong. The hardware, impossibly, was still alive, but the data inside the signal was completely corrupted. Engineers at the Jet Propulsion Laboratory in Pasadena stared at readouts that made no sense. The probe's attitude control system, the system that keeps Voyager pointed at Earth, was routing data through the wrong onboard computer. A computer that had not been used in decades. A computer that was, effectively, broken. The numbers coming back didn't match any format JPL had on record. The probe seemed to believe it was in a physical orientation that doesn't exist. 45-year-old hardware, operating in interstellar space at temperatures approaching minus 270 degrees Celsius, was behaving like it had lost its mind. Engineers had no way to reach it, no way to run a diagnostic, no way to reboot it, not in real time, not from here. Here is the obvious explanation. Old hardware fails. Electronics degrade. Cosmic radiation, the kind that saturates interstellar space, bombards circuits, flips bits, corrupts memory. You'd expect this. NASA planned for it, but that's not what happened. The hardware wasn't failing. The instruments were still functional. The power systems were still online. Voyager wasn't dying. It was confused. And there is a massive difference between a machine that is breaking down and a machine that is transmitting something it shouldn't know how to transmit. JPL engineers spent nearly a year trying to decode the signal like a cipher, working backward from garbled output to find out what the probe was actually trying to say. But that's not even the part that worries them. In April 2023, engineers finally cracked it. One chip, a single memory chip inside the flight data system, had been corrupted. Just 3% of the system's memory. But that 3% happened to contain the code that formats all outgoing science and engineering data before it gets beamed across 25 billion kilometers. That one corrupted chip was poisoning every signal Voyager sent. Here's the strange part. It shouldn't be possible at all. Not the chip corruption. That happens. What shouldn't be possible is this. NASA engineers, working with 45-year-old documentation, communicating across interstellar space in 45-hour round-trip conversations, wrote new code, rerouted around the broken chip, and restored full communication, with a probe running on less electricity than a refrigerator light bulb. A probe whose signal, by the time it reaches Earth, is 20 billion times weaker than the battery in a digital watch. They fixed it. And Voyager 1 started talking again, sending back science data from a place no instrument has ever sampled, measuring the density of interstellar plasma, detecting particle winds drifting in from other stars. A 1977 machine, alone in the dark between solar systems, still transmitting, still collecting, from a location no other probe has ever reached. Think about what that means. The most distant object humanity has ever built is still alive, still measuring the universe. And the only reason we almost lost it, the only reason 50 years of the greatest journey in human history nearly went dark forever, was a fragment of corrupted memory smaller than a paragraph. But there is something else. Something the signal is quietly telling us that scientists are still processing. Voyager 1 is sampling interstellar space in real time, a region no model fully predicted. The particle density is different than expected. The magnetic field orientation doesn't match the simulations. The boundary between our solar system and the galaxy is behaving in ways that contradict decades of accepted theory. The probe is out there, still transmitting, and what it's sending back is slowly, carefully rewriting the textbooks. So here is the question nobody is answering. If Voyager's data is already challenging the models, if the edge of our own solar system doesn't look the way we thought, what else did we get wrong? Drop your answer below, because I'm not sure the scientists have one yet.